All right, we're at 4 after, so I think we're good to go ahead and get started. So I will kick us off here. Thanks to everybody for joining us today. We're super excited about this topic that has been new as of the last couple of versions of Airflow. So dynamic tasks are usually super relevant for a lot of different use cases and really powerful. So tomorrow's going to go through how to use them in all sorts of different ways. Before we kick it off, just a couple of logistics. As I mentioned a minute ago, the recording will be available after the fact. So you will get an email with a link to the recording, as well as all of the materials that we go through today. So the slides and then the repo that has all the code that tomorrow is going to go through. So no need to write anything down in terms of links or things like that. You will get all of that after the fact. Also, definitely throw any comments you have in the chat as we go through. You can also use the Q&A feature in Zoom for any questions. I will be answering any questions that I can as Tamara is presenting, so just throw them in whenever you think of them. And if for some reason I can't, or we need to demo more to answer the questions, we will have time at the end to address those. So definitely let us know what you're thinking and if anything is unclear. And I think with that, we are good to go. So I will go ahead and hand it over to Tamara.
Yeah, welcome everyone, also who joined in the meantime to this webinar on dynamic task mapping in Airflow. We have quite a lot of ground to cover, so I'll jump right in. Okay, one thing before we get started with dynamic tasks, if you are very new to Airflow and you haven't used it yet, in this webinar, we will assume that you have some experience with operators, with writing DAGs. If you are new, you can still gain something from watching this. You will learn about a very new and exciting feature. But we also recommend that you will look at one of our Intro to Airflow webinars, either an upcoming one or watch the recording of an older one to get familiar with the basics, because we will not have time to cover the basics in this webinar. And Kenton already mentioned this in the introduction. Dynamic task mapping is fairly new. It was added in Airflow version 2.3. So earlier this year, late spring, and heavily extended in the new, like I think it's like a month ago now, Airflow 2.4. So if you can't use these functions, make sure you have your Airflow version updated. And in any case, especially Airflow 2.3 and 2.4 added many exciting features. We highly recommend you update. And we probably say this in every webinar, but it's really worth it. With that said, let's jump in. To understand what a dynamically mapped task is, you have to first think about what a normal task is in Airflow. So normal tasks are generated when the DAG file is parsed. So the scheduler, the Airflow component, parses your DAGs folder. Every 5 minutes, it passes it for new DAG files, and every couple of seconds for changes in the existing DAG files. So you know this when you are developing a DAG and you add a task, this new task will be added in the Airflow UI, usually after a couple of seconds. So this is how normal tasks get added to Airflow. And to change the number of tasks in this situation, you have to actually change your DAG code. So if you want another task, you have to either define a new one, or you have the tasks in a loop and you have to make the loop run more times. But every change in number of tasks needs a change in the DAG code. Dynamically mapped tasks, on the other side, are generated dynamically at runtime. So when the DAG starts running, it doesn't know yet how many mapped task instances, so how many copies of a certain task will run. It signifies that in the Airflow UI you can see that on the lower right corner of the screen, you have the extract dynamic task, and we have these empty brackets. This means the DAG hasn't run yet, but this is a dynamically mapped task, and Airflow doesn't know yet how many mapped instances of that task it will run. So the number of tasks can change without any code changes. So every time this DAG runs, at the point where it reaches this dynamically mapped task, it will look at the input, and I will show you how to do that later, that this task is getting, and then it will decide, do we need 2 copies, 10, or 1,000 of this task? Of course, Airflow is used for many, many things worldwide. So there are a ton of use cases for dynamically mapped tasks, but I want to focus on 2 here. One is in ETL. So often you have, for example, an S3 bucket, or you have a data warehouse with records. And then you have one task, and you really want that task to happen once for every file in the S3 bucket or once for every record returned, but you don't know in advance for every DAG run. For example, if you have a daily DAG run every day, how many files will be in that bucket, how many records will be in that table. So you can use dynamic task mapping to have the same DAG always generate the right amount of tasks for this day. And you can also use the .map method, which I'll also cover later, to selectively skip processing certain records. This is really useful if you have files in an S3 bucket, and for example, you want to skip all of those that have a certain prefix, or you want to skip all of those that contain something. You can see on the bottom of the screen one such example DAG that is an ETL DAG. It lists files in an ingest bucket, reads their contents, looks at whether the content is an integer, then it generates source destination pairs, and the copy files as free task and the delete content ingest bucket task are both dynamically mapped tasks. So how many mapped instances of those tasks will run depends on how many files are in the original bucket, which can change every time the DAG is run. Another common use case is in machine learning. If you train models and you have different sets of hyperparameters, and you want to have the observability that you have one mapped task instance per set. And you can also, if you use dynamic task mapping, it's very easy to create a cross product of the inputs, which is super useful if you have hyperparameters and you want to test all possible combinations of them. I kind of touched on this already, but what are the benefits of using dynamic task mapping? If you have used Airflow for a while, you have run into this issue. You had some changing input, like objects in an S3 bucket, and then you needed to do a certain action on these objects, but you didn't know in advance how many there would be. And the way we solved this in the past was by creating a custom Python function that somehow fetches the list, and then it has a loop in it, iterates over them, which of course means you cannot use all of the over 1,000 now traditional operators that exist in Airflow. You have to write your own function, sometimes with your own hooks and connectivity. And it's also not atomic. It's pretty monolithic. You have a huge task, and if that task fails, you don't know because of which file it failed, or if it failed somewhere more upstream in fetching the list, or what really happened. So with dynamic map task instances, you can really have the atomicity of having one map task instance per file, per record, or per whatever input you need. And you have the observability. You see that in the screenshot below, we have 5 mapped task instances, and 2 of those mapped task instances were skipped. So you know exactly which ones were skipped, which ones succeeded, and you can preserve this history over all of your DAG runs. So if you run this DAG every day, and after a month you want to look back how many mapped instances happened a month ago and which of those succeeded, you can do that, which is not possible if you have a monolithic task. And dynamic task mapping can replace some instances of dynamic DAGs. At this point, you might ask yourself, what is a dynamic DAG? It's simply a term that we use for all ways to programmatically create DAGs. As you know, if you used Airflow before, it's all just Python, and you can do all the shenanigans that you can do with Python. So you can theoretically have a file that creates the code for many DAGs. It's called the single file method. Little caveat here, this can cause performance issues if you create a lot of DAGs. You can have one file that creates multiple Python files in your DAGs folder. It's called the multiple file method, and can do that with a script. So there are many options here. And the use cases are mostly if you need to map over, or if you need to have some dynamic function over not mappable parameters, or if the changes to your DAGs are less frequent. So whenever you're thinking, I really would like to have one DAG per X, one DAG per input to my pipeline, or one DAG by sub pipeline, then you might be looking at dynamic DAGs. And shameless plug, we have a concept guide on our docs side on dynamic DAGs too. But what we recommend as a best practice is to, whenever possible, use dynamic tasks instead, because they don't cause these performance issues. The number of DAGs stays static, and they make the DAGs themselves more flexible. So there are no code changes needed, which are still needed with the dynamic DAGs method. And whenever you ask yourself, I have this task and I want this task to run once per X, once per object in the S3 bucket, once per record, then you are looking at dynamic tasks. And of course, you can use dynamic tasks within dynamic DAGs. There's no rule against that. Okay, I talked a lot about the benefits and when to use them, but now how do we actually implement dynamic tasks? A dynamically mapped task is defined by instantiating one operator, the way you always do. But instead of just giving it its usual parameters, you divide those parameters up and giving it to the operator either in the .partial function, which contains all the static parameters, so oftentimes the task ID or other parameters like the destination bucket in this free parameter. And then you put all the dynamic parameters, so the things that should change in between the map task instances, in either the .expand or the .expand quarks function. I will show how this is put all together in a second. And what happens now is this task automatically turns into a dynamically mapped task, and only at runtime, so only when the DAG executes up to this point, Airflow will decide or will compute how many mapped task instances are actually needed. And this can change from DAG run to DAG run. Couple of notes. Yes, you can use the output of an upstream task to map over. This is actually one of the most common use cases and one of the exciting parts of this feature. Yes, you can map over multiple parameters. This was heavily expanded in Airflow 2.4. And there are a couple of parameters that you can't map over. These are usually parameters that the scheduler needs to decide how and when the task is executed, and usually parameters of the base operator, like the task ID or the pools parameter. You can't map over those. How many times can you map the same task? The limit is your imagination, or much rather your computing power. By default, there's actually a setting in the Airflow settings guardrailing you. It's called max map length, and it's set to 1024. So if you don't change any settings and you try to map more than 1022 task instances on the same task, it would fail. But you can change that setting, and then the limit is really only the computing power you have available. And I've actually seen more than this amount. The most I've seen is 2000 map task instances so far on the same task. Okay, putting this all together, we get the basic syntax of dynamic task mapping. I here put the traditional operator and the task flow operator side by side, also as a little plug for the task flow API. You can see those tasks do the exact same thing, but the task flow API is a lot leaner and I think easier to read. So if you haven't used it yet, I recommend you try it out. I'm going to start with the code on the right-hand side. We first define our task API task called sum x and y, which simply sums together x and y. And then instead of just calling it like normal, we call it with .partial first. Now, partial takes all the parameters that stay the same in all map task instances. So y will always be 19. Then we call .expand, where we pass in x equals 1, 2, and 3. So we pass in a list. You can only map over lists and dictionaries. And we have 3 options here. So this will end up with 3 map task instances. One will be 1 plus 19, 2 plus 19, 3 plus 19. And on the bottom of the screen, you can see what this looks like in the Airflow UI. After it has run, it shows the 3 in the brackets, which means the last time this task run, it had 3 mapped task instances. We can do the exact same thing with traditional operators too. On the left-hand side, you can see the Python operator. Here we have to pass the task ID and the Python callable explicitly. And we pass in 19 for y again with the OP quarks parameter, which again stays the same for every map task instance. And here we map over the OP args parameter. And you can see here it's a list of lists. This is just because the OP args parameter always expects to receive a list, even if it only has one element. So that's one thing I recommend. If your mapping doesn't turn out the way that you expect it to, double check in what form your parameter expects its input, and make sure that every element of the list that you put in is in that form. But this traditional operator does the exact same thing as the task flow operator on the right side, and we end up with the same result. I mentioned earlier there's .expand and .expand quarks, and you might have wondered what's the difference. That's actually a question we get quite a lot. .expand only accepts keyword arguments, and it can take several keyword arguments, but it will always create a cross product of those. So if I would pass the code on the left-hand side to the expand function, I will end up with 9 map task instances. So every possible combination of the inputs. I have 3 inputs each for 2 keyword arguments. That would mean 9 map task instances. Little side note, the order is not guaranteed in which those task instances were mapped. And the .expand quarks function only accepts a list of dictionaries, and it's used to pass sets of keyword arguments. This was added very recently, so if you don't find that, make sure you're updated to Airflow 2.4. The syntax to pass your input into this function is shown on the right-hand side. You have a list, and the list contains several dictionaries. And within each of those dictionaries, you can define as many parameters that the operator needs as you want. And Airflow will create 1 mapped task instance per dictionary that you put in. Here I put in just 2 keyword arguments in each dictionary, but you could put in 10 if your operator takes 10 different keyword arguments. So you have a lot more fine-grained control over what exactly happens to each map task instance. This is what this looks like in code. On the left-hand side, we use .expand, and we pass in 2 keyword arguments to the bash operator, bash command and env. And this will create all possible combinations of the 3 bash commands and the 3 environment variables, which in total is 9 map task instances. So it will once print out each word, hello, tea, goodbye. It will once print out the length of each word, and once print out each word with each E replaced by an X. That's what the 3 bash commands do. On the right-hand side, you can see the same inputs, but put into the format that expand quarks takes. Here we have the list of dictionaries, and the first set of keyword arguments is just print the word, and the word is hello, so it will print hello. The second one prints the length of a word, which is the word tea, so free. And the last one will print the word goodbye with every E replaced by an X. So we only have 3 mapped task instances in this case. Okay, so far I covered partial, expand, and expand quarks, which are all functions that you call on the task that is dynamically mapped over. And next I will show you 2 super helpful methods that you will call on upstream elements that you pass into the dynamically mapped task. And the first one is .zip. If you're familiar with Python, you will immediately think of the built-in Python function that is called zip, which forms a zip object of n tuples out of n iterables. That is just an overly complicated way of saying it kind of takes inputs that are iterables or lists or dictionaries and zips them together, like on a clothing, the zipper. So you will end up with the first element of each input in one tuple, and then the second element of each input in another tuple, and so forth. This is super useful if you have an operator that takes several positional arguments, which in most cases will either be the Python operator or the decorated Python operator, or maybe you have a custom operator that has a parameter that takes several positional arguments. And you can use the Python zip object now. So you can either use the built-in function and pass one of those zip objects into your dynamically mapped task, or you can also directly zip together outputs from upstream tasks. This was also added in Airflow 2.4. And you can simply call your upstream task. My task 1 was defined with the task flow API, so I can just call it like that. Then you add the .zip method, and then you can add in my task2 and my task3. And this will do the same as the built-in Python zip function and zip together all of these inputs or all of these outputs from upstream task to be the input of your dynamically mapped task. This is what this looks like in code. So we have our first task that just simply retains a list with 1, 2, 3. We have our second task, which retains a list with ABC. And then we have the task that we actually want to dynamically map over, which is called multiply. Multiplies the number by the letter, which you will end up with A, BB, and CCC, each in their own map task instance. And now the easiest way to pass the upstream outputs to this dynamically mapped task is by first calling .partial. Little side note, if you don't put in anything to .partial, you technically don't have to call it. I like to call it anyway to remind myself that it's here. And then you add .expand, and expand always takes a keyword argument, so you have to put input equals. And here we simply zip together get 1, 2, 3 and get ABC. So what happens in this second to last line is Airflow will take the first element of get 1, 2, 3, so 1, the first element of get ABC, A, so you end up with the tuples 1A, 2B, and 3C, which are the inputs, and then we can simply index into the input and then do whatever we want with it. Of course, this is a very simple function, so it fits on the screen in the presentation, but this function could be as complicated as you want it to be. I've shown it so far with the TaskFlow API, but of course you can also zip outputs from TaskFlow tasks together with traditional operators, or just zip outputs all from traditional operators. For that, you have to put the task object. So my task in this example was defined using a traditional operator, and then you put it into the XCOM object that you have to import. And then you can use the same syntax to zip it all together. Now, the built-in Python function, as you probably know, zip always only looks at the shortest of your inputs. So if you have an input that has a length of 3 and an input that has a length of 10, it will only consider the first 3 elements of each. And there is actually a function called zip longest from the editors package that does something else that looks at the longest input, and then you can fill up the missing values. You can do the same thing here with the .zip method. You can simply pass in any value to the fill value parameter that you would define directly in the .zip method, and then it will fill up any missing elements of the shorter lists. And you can provide these zipped arguments to any mappable parameter that takes several positional arguments. The second super helpful little method is called .map, and this allows for a one-to-one transformation of elements in a list. So right before your elements are mapped over, you can transform them. I'm very excited about that because I've run into this issue pre-Airflow 2.4 that I had an upstream task that it was using a traditional operator doing a lot of things under the hood that I really didn't want to recode, but it returned my values slightly in the wrong way. So for example, you have a task that returns full paths to files, but you only need the file name, things like that. And now with .map, you have a very easy way to take in an upstream list or an upstream iterable and change every single element of this list. Yes, this can use any transformation function actually. So .map takes one argument, one positional argument, which is any Python function. So you can have a very simple function that simply changes a string, or you could have a whole script that you import from somewhere else that runs a very complicated transformation on every single element of this list. This also adds the possibility to conditionally skip certain mapped inputs. I mentioned this earlier in the use cases, but for example, if you have files in an S3 bucket and you want to skip you want to copy some of them, but only the ones that, for example, don't contain a prefix or don't contain a certain string, you can do that with the .map method. And a little side note, this does not add an extra task in Airflow. So you might expect this because you are defining a Python function, but it's not an Airflow task. It's actually part of the upstream task. This is what .map looks like in code. So again, we have a very simple function that simply returns 1, 2, 3, but unfortunately, and this is kind of a placeholder for a traditional operator, it returns its output slightly different than we would want it to. It returns our numbers as strings. What we can do now is we call this function, get 1, 2, 3 strings, and then we add the .map method, and then we can pass any transformation function to this .map method. Note that the transformation function is really only a Python function. We don't add a add task decorator. And this function simply takes in the string and turns it into an integer. Now we end up with a transformed list. So this turn string into integer function runs over every single element in the upstream input. And then we can put the transformed list, give it to our dynamically mapped function, which adds 23 to any integer. And then we can map over this as usual. And this will work and not error because it is a string. Okay, I know this was a lot, so you can take a second to breathe while I hop over into the demo and quickly refresh. Okay. So those were a lot of new functions, but they are very powerful and they can take your DAG offering to the next level. First, I'm going to show you a very basic example to kind of remind you of the basic syntax. We have an upstream function, get 1, 2, 3. Then we have a simple dynamically mapped task that is called multiply by y. You can see here I already ran this, and we have had 3 mapped task instances the last time. And you can actually optionally add a downstream task, which could be a reducing task. If you come from a CS background, you might, or have been in data engineering for a while, you might have been thinking the whole time, hey, this sounds like MapReduce. And yes, MapReduce was the inspiration for this feature. And you can basically see the dynamically mapped task as the map, and you can optionally have a reduce function. You don't have to have that though. You could simply have a function here that doesn't act on any of the input values, or you could have no function after the dynamically mapped task at all. Let's take a look at the code. Very short and simple DAG. We have our imports, we define our DAG, then we have the upstream function or the upstream task, which returns 1, 2, 3. We define our task that will be dynamically mapped over, which multiplies x by y. And then we add in our arguments to partial. Again, this is these inputs will stay the same over every map task instance. So y will always be 42. And then we expand over x, and we pass it the output of this upstream function. So 1, 2, 3. And this is why we had 3 dynamically mapped task instances. And here we have the optional reducing task, which takes in these multiplied values and just sums them up and returns the total. You don't have to have this, but if it's useful for your use case, you can always add a reducing task. Now, if I run this task, you can actually see how Airflow doesn't know yet how many map task instances there will be. Only now it arrived at this task, saw that the upstream output had 3 elements in its list, and decided to create 3 map task instances. And if we click into one, if you know the grid view, you can have all your information about a certain task here if you click on it. And with a mapped task, you can also simply click on it and then click into a mapped instance. And then we can see in the logs here, we have 126, which is 3 times 42. So it worked out. Little side note, if you're thinking, hey, why have I never seen my logs show up in the grid view? It's because this was added in Airflow 2.4. And this is my personal opinion, but even if there was no other feature added in Airflow 2.4, I think this is worth it simply as a quality of life improvement. Okay. Now let's go to our second example. Again, a very, very simple simple DAG. We have our upstream task that's called list files S3 bucket. So we list the files in the S3 bucket. We use a traditional operator for it. And then we use the S3 copy object operator to copy files to another S3 bucket. You can see here in the brackets, we have 11. So last time I ran this DAG, we actually had 11 instances of this task. I've shown you how to see them in the grid view, but you can also in the graph view, simply click on the task. And then up here, you can select each individual mapped task instance. And then you can click into the log, into the XComs rendered, everything as usual. And you can also clear and rerun an individual map task instance here. Looking at the code for this, we have our imports. Little side note, of course, these two operators have to be imported from the AWS provider. If you're using the Astro CLI, as I'm doing, then the AWS provider will come pre-installed. But if you're using another Airflow variant, then you might have to install the AWS provider to run this DAG. Then we have my two very creatively named, I know, S3 buckets. We define the DAG. The upstream task simply returns a list of all keys in an S3 bucket. And then we have the downstream task here. I will say what the code in the middle is doing in a second, which copies each of those files in another S3 bucket. Now, we have a little problem here. The S3 copy object operator always needs a source bucket key and a destination bucket key. Those two parameters are mandatory. So we have two keyword arguments that we want to map over, but we want to map over it in sets. We don't want to have a cross product. So this is a great example for when to use expand quarks. So we know we need to use expand quarks. We need to pass it a list of dictionaries, which contain each a source bucket key and a destination bucket key. But as you remember, our upstream traditional operator simply returns a list of keys. And what I showed earlier is that this is one of the ways, one of the opportunities to use the .map function. So what we do here is we take the list files S3 bucket task. We use the output object of it. In the example in the slides, I showed how to do this with a TaskFlow API task, where I just simply called it and then called .map on it. If you use a traditional operator, you have to add .output to get the output object. Then we call .map. And here we can, again, input any Python function that does any transformation on this list. And this is what this function in the middle is doing. It takes in each of those keys. So it kind of iterates over this list. And for each of the keys that this upstream task returns, it will create a dictionary with a source bucket key. So we add the bucket name, and the destination bucket key. So we add the second bucket name. And we actually change the file name slightly to signify it was copied. And then we return this source destination pair, dynamically map over. So let's hope I haven't been locked out of AWS. I haven't. This is my first S3 bucket. And you can see here it contains 3 files. And my second S3 bucket contains no files. So let's run this DAG and see if it works and copies our files over. So we trigger the DAG. Airflow doesn't know yet how many map tasks there will be. We had 3 files. We know it will be 3 map tasks. It says all of these tasks were a success. So let's double check. We have to refresh the page. And our files showed up here with the new name. Now, I told you earlier with dynamically mapped tasks, you don't have to change the code for a changing number of inputs. So if you imagine it was the next day, and to look at my other screen for a second, and instead of 3 files, 5 would be dropped into this S3 bucket. So let's add 2 additional files. Simply upload our 2 additional files. Again, I'm bad at naming things. And let's run the DAG again. Airflow doesn't know yet how many files there are. Now it receives that information from the upstream task. It maps 5 times. All of them are running. all of them succeeded. Let's double check. A second bucket. There are now 5 files in our bucket. Okay. So if you are keeping track, I've showed you partial, expand, expand quarks, and map. Zip is missing. So let's look at this also very simple DAG. We have 3 upstream tasks this time. We have one task that lists files in one S3 bucket, one that lists them in another S3 bucket, and one task that runs a query against a Snowflake data warehouse. And then we have one dynamically mapped task, which last time had 6 mapped task instances that compares dates and log files. This code is a little more complicated, and I will not read all of this out to you, but you will be sent the link to the GitHub repo so you can read this yourself. But we have again our imports. We name, if you want to run this yourself, you will have to rename these, obviously. We define which S3 bucket to use, what Snowflake table to use, start our DAG. These are the 3 upstream tasks. So we list the files in S3.1, list the files in S3.2, and query our Snowflake data warehouse. And then this task down here, the whole thing, is a bit of a complicated task comparing different entries in the S3 bucket file names and in the Snowflake database. So what this does basically, it makes sure that the date in the file name matches up with the dates in the Snowflake database, and that the customer in the file name also matches up with the Snowflake database. If this matching is true, it will simply log matching entries on that date. And if there would be any mismatch, it would raise this value error with this custom message that tells us exactly what didn't match. This is the task definition. And down here, we actually call the task. Here, I didn't call .partial, just to show you that I wasn't lying. You don't actually need it. And then if you don't pass anything to it, and then we call .expand. And here we have one keyword argument to pass to this function. It's called input tuple. And here we zip together the outputs of all the 3 upstream tasks. So we can take the x, argument of the first task, add the .zip method, and then zip it together with the output from the second task and with the output from the first task. And since I don't know yet whether there will be of the same length, I add the fill value missing entry. But you don't have to do that. If you don't do that, it will simply look at the input that is shortest. If you do it, it will take the input that is longest and add missing entry for each of the potentially missing elements. All right. Let's hope Snowflake NS3 is nice today. All our upstream tasks are running. Airflow doesn't know yet how many map task instances there will be. S3 was queried, or S3 ran. Now we query our Snowflake database. This will take a second to make the connection. And now it arrived at the dynamically mapped task. And because there were 6 entries, it will run 6 map task instances. And they all succeeded. Now there's one thing left that I want to show you, which is how to skip certain map task instances, because it needs an object that you may not have used before in your DAG offering. Here we have a DAG with 3 tasks. We list strings. Then we have a mapped task that prints the strings with some adjustments. Last time this ran, it had 5 mapped task instances. And then we have a downstream task that simply says hello. If we look at the code, again, this is explanation that you can read later. We make our imports. Here we actually have to import the Airflow skip exception for this to work from Airflow exceptions. We define our DAG. The upstream task here simply returns a list of strings. And you can already kind of tell I added skip to the start of some strings, and my goal is to skip these strings. This is the mapping function. So if you want to skip certain map task instances, the .map method is what's going to help you do that. So what we do is we call this function here. Then we add the .map method. We pass in our mapping function. This time it's skip strings starting with skip. So what's going to happen in this line is Airflow will go over each of these inputs and it will run it through this if-else statement, which if it starts with skip, will raise an Airflow skip exception. But if it doesn't, it will simply add an exclamation point to the word. Now we have a transformed list. So we use the .map method to transform the output of the upstream task. And we can pass this transformed list to the task that we actually are dynamically mapping over, which simply says hi or says at say and then the word. So it would be say hi, say hola, and say hey. Again, this is very simple. We take the function, we add .expand, and we pass in this transformed list to the keyword argument. I'm repeating this so many times because this has tripped me up when I first started using dynamic task mapping, and I forgot this keyword argument quite a few times. And now we have a downstream task, which is simply a bash operator that says hello. Why did I add this downstream task, which is an example of having a downstream task that does not do a reduce step? It's because if you skip certain map task instances, your downstream tasks will also be skipped if you use the default trigger rule. The default trigger rule is called all success, so only run if everything upstream has been successful. And if certain map task instances were skipped, that's not true anymore. So this bash operator would not happen unless we change the trigger rule here. I change it to all done, so this task will happen no matter what happens upstream. If tasks fail, tasks are skipped, as soon as all upstream tasks have happened. Okay, and ones of you who were reading the code with me might be wondering, hey, what's this? I haven't shown this before. It's the second way you can put limits on your map task instances. So this parameter called max active tis per DAG is a limit on how many mapped instances of this task can be actively run at any point over all the DAG runs of this DAG. Why is this useful? Maybe you have a mapped task that sometimes has 1,000 mapped task instances, but you also have other tasks that run in the same DAG on parallel, and you don't want all your workers to be taken up by these mapped task instances. And this is a way to say, okay, at maximum, I want 2 of these mapped task instances be running for all of the DAG runs of this DAG. Okay, let's run it and check it out. We're waiting to know how many map tasks there will be. 5, because we have 5 input strings. You can see, or you could see for a second, that only 2 were running actively at any point. And it skipped the first one and the third one, which we can double check, were the 2 that we had added skip to. And our downstream task was running as expected and said hello to us. This run actually I did before I changed the trigger rule. And here the downstream task was skipped because it was expecting everything upstream to succeed, but 2 tasks were skipped. All right. Now, before we go to questions, let's jump back. I know this was a lot, so I thought I'd do a quick recap slide. Dynamically generated tasks are generated at runtime based on mapped inputs to 1 or more parameters. And the functions that you call on your dynamically mapped tasks are called .partial, which contains all the static inputs, .expand, which maps over 1 or more keyword arguments, creates a cross product if it's several, and .expand quarks, which maps over sets of keyword arguments and takes a list of dictionaries. The 2 helpful methods that you can call on upstream outputs are called .zip, which creates tuples for parameters that take several positional arguments, like for example, the OPArgs parameter of the Python operator, and .map, which is simply a way to change the upstream output one-to-one, like change each element in the upstream list. Okay, I hope you want to know more about this and use it in your own DAGs. You can, of course, rewatch this webinar, look at the example code that will be in the repo. You can also read our guide on dynamic task mapping. Maybe just for a second, because if you're familiar with our guides and you click on that link, you will at first maybe think, what has changed? We actually migrated our guides to be in our docs site. So now you have a much more functional search. You have a dark theme, as you can see, but you can also have it bright, but it's the same content. So you can read up on here, or you can also join on the live next Tuesday already, where we dive deeper into mapping on multiple parameters. Okay, with that, I think we're ready for questions.
Awesome. Thanks for going through all of that, Tamara. That was a lot of really great information. You actually covered a lot of the questions. I did a lot of saying in the chat that you're just about to talk about that, so that was great. We do have a couple more that I haven't addressed so far, so let's go into those. The first is, so you mentioned that there is a limit of 1,024 mapped tasks. And the question is, what happens if you exceed that? Will there be an error, or will the task not be expanded? Obviously, you can change that parameter if you know you want to increase it, but what happens if you just hit that limit?
The task will fail, and actually what happens, I haven't tried this out yet because I like my computer and I don't know how much it would like it. But according to the official Airflow documentation, the upstream task would fail that provides the input. So if you have the upstream tasks that returns a list with 1,025 elements, then that task would actually be the one failing.
Yeah. Got it. Thanks for covering that. A little bit unintuitive, potentially, but yeah, good to know if you're actually dealing with high scale. Another question that I think maybe looking at your example on mapping over the results of another mapped task, but one of the questions was, what does the XCOM look like for a mapped task? Since we're asking all of those task instances share the same ID, so if you need to access like the XCOM of a specific instance of the mapped task, how do you do that? How does it look?
That's a really good question. I'm not sure whether I checked that, but we can do. So we click on the square in the grid, and then we click on any instance and on XCOM, and it simply has that one return value. So for every mapped task instance, the XCOM will return its own part. Yep. Not sure if I can add more. Maybe the question is also how to access that specific XCOM. And I actually have never tried that. I imagine, yeah, I'm not entirely sure how you would access that specific XCOM. I imagine you could add like the map index somehow, but that's something I'm going to read up on. That's an interesting question.
Yeah, thanks to, that was in the chat further up, so thanks to whoever asked that. We will definitely make a note to maybe add that to the guide. I do know that, yeah, so the task instances are indexed based on their map index that's applied to them. So you should be able to access specific information that way. Let's see, a couple other questions.
I see one that was just asked. Is there any way to use expand with multiple keyword arguments, but not allowing it to do a Cartesian product? Unfortunately not. So this will always happen. Might be changed in the future, but if you use expand and you add several keyword arguments, it will always make this cross product. But for all use cases where you need specific keyword arguments to be together, you can use expand quarks. But you have to update to 2.4 for that.
Yes. And we have one other question. I think I'm actually going to take this one in the Q&A, asking what is the benefit of using dynamic task mapping on your Airflow operators or Airflow tasks as opposed to just doing this in your Python scripts that you might be running? That's a really good question. And so I touched on this a little bit at the beginning, but just to highlight, I think this is kind of my opinion, but the biggest probably benefit of doing this is that atomicity in your tasks, which gives you both more sort of visibility in the UI, obviously, like we're looking at here, where you can see each individual task instance. You can also see in this case where you have, some tasks instances that were skipped. You might have some that fail and others succeed. So one benefit is you just have much more granular control when you've mapped over that individual Airflow task. So if you only need to rerun 1 out of 50, you only have to do that as opposed to rerunning the entire task where it all happens again. Obviously, you might have logic within your Python script to manage that as well. But this is just a way to kind of really take advantage of all of Airflow's features for implementing that kind of logic. The other huge benefit is that you maintain all of your history. So as Tamara showed, you might have different numbers of mapped instances every single DAG run. You can still see that. So if you're running everything in a monolithic task because you've implemented your own logic, it's always going to look the same. So it may not be super straightforward for you to figure out, okay, if I'm processing files, did I process 5 today and 3 yesterday or 100 tomorrow? Something like that. Whereas with dynamically mapped tasks, you get to see each individual one and you maintain all of that history. So that's also a benefit over dynamically generating your DAGs as well. So hopefully that answers that question. All of that to say, there are still use cases where you might want to manage it within your Python file or use dynamic DAGs. So this is just kind of another tool in your toolbox or however you want to do that. Great. So I think that we've got all the questions so far. I'll give it 1 minute since we have maybe 2 more minutes left here in case anybody wants to throw any last minute ones in the chat.
Also curious how many people have used dynamic tasks before who are here. Like for how many was it more of a reminder, repeater, or new features? And how many are completely new to it, if someone wants to share?
Yeah, and just for that last question, if you're looping over the output of a task, in this case, we're not considering that a dynamic task. That is sort of the old school pre-2.4 way of creating dynamic tasks within your DAG file. That way of doing it, again, the downside is you're creating those tasks at parse time. So that can potentially have performance implications, and you're also not going to maintain that history. So when we refer to dynamic tasks now, we're referring to dynamic task mapping as of Airflow 2.3 and 2.4. Oftentimes, this is a great replacement for those loops that you might have had in your DAGs. Awesome. Love to see this great feedback. This is a super exciting new feature. Like Tamara said, we will have more content on this. We're going to do a super short, one of our Live with Astronomers next week on mapping over multiple parameters. That'll be a way to kind of dive in deeper and get another, another session on that if you're interested. But otherwise, thanks everybody so much for joining us today. Super happy to have you here, and we hope you have a great rest of your week. Bye, everybody.
Thank you for joining, and bye, everyone.